name is Emma Hutchinson.
And I'm Josh Lappin.
And we are co-leaders of the Climate and Energy subgroup of Students for a Sustainable Stanford. We are so excited to have you all here today and are honored to welcome 6 incredibly talented Stanford professors to discuss the challenges and opportunities of hydraulic fracturing in today's economy.
We would first like to introduce our moderator. Pamela Matson is the Chester Narramore Dean of the School of Earth Sciences, the Richard and Rhoda Goldman Professor of Environmental Studies, and a senior fellow at the Woods Institute for the Environment.
Her research addresses a range of environmental and sustainability issues, including the sustainability of agricultural systems, the vulnerability of particular people and places to climate change, the consequences of tropical deforestation, and the environmental consequences of global change in the nitrogen and carbon cycles.
Dr. Matson is the author of numerous scientific publications and books, including the National Research Council volume titled Our Common Journey, A Transition Towards Sustainability, and Seeds of Sustainability, Lessons from the Birthplace of the Green Revolution. We're so honored to have Pamela Matson as our moderator for today's panel. Please welcome her.
Well, thank you, Emma and Josh, and thank all of the students from Sustainable Stanford for organizing and convening this gathering. Thank you, to all of you for being here and for coming to engage in this discussion. We're here to discuss one of the most important issues of this decade, if not beyond, and we have a great team of Stanford faculty to help lead us in that. The use of horizontal drilling and hydraulic fracturing technologies is enabling the production of huge quantities of natural gas. And that fact and those technologies have completely changed the energy landscape in a very short period of time. Most of us recognize that the global availability and scale of this resource presents some wonderful opportunities, potentially, but also some very serious challenges. And the panelists that are here today are very well suited to helping us all understand those opportunities and challenges. They all have extremely great backgrounds in research and education in these areas, and I think they will bring to us a whole lot of really important information. Now, our plan for this noon is to first of all ask each of the panelists to do a very brief introduction of themselves and tell you a little bit about what they do and what they think is critical about this issue of natural gas and fracking. Then we'll have a 5-minute primer, a very short presentation that explains a little bit about natural gas and fracking, and Marc Zoback will do that for us. And then we're going to go right into questions and answers. And I'm going to start with a few of my own, but we'll be encouraging all of you to ask your questions and join in the discussion. So a bit of housekeeping, just so that you know, we are videoing this entire discussion, and that video will be available on the Students for a Sustainable Stanford website and also on the School of Earth Sciences website, probably later in the week. NBC here is videoing, and plans, or at least possibly, will use parts of this for a segment on the Today Show. And KZSU will be broadcasting parts of this later on in the week or so. So that's the plan for the day, and now let's just turn to the panel and ask them to introduce themselves, and we'll start with Professor Sally Benson.
Okay, good afternoon. It's wonderful to see so many people here interested in this topic. I'm Sally Benson. I'm a professor of energy resources engineering in the School of Earth Sciences, and my specialty is in subsurface flow and transport. And actually, the first job I had right when I left my undergraduate work was to do hydraulic fracturing on geothermal wells. So I have a little history with this, but I'm not going to offer that perspective today. Mostly what I work on is to develop technologies that will enable us to significantly reduce greenhouse gas emissions while at the same time continuing to provide affordable and accessible energy supplies to people all around the world. So what does it mean that we have hydraulic fracturing techniques? Well, basically it means that rocks that we heretofore thought were unproductive, meaning they'd never be a natural gas resource, can now in fact be produced. And if we look over the next 2 to 3 decades, we can anticipate that natural gas production will double globally. Some of this will be from hydraulic fracturing of shale, and other will just be conventional gas supplies that are also increasing. So from a greenhouse gas perspective, the environmental benefit is that when you produce electricity from coal, and from natural gas, it has about half the emissions that you would have from coal. It also has lower particulate emissions, it also has lower radionuclide emissions and lower acid rain producing pollutants and so forth. So that's the good thing. But, now this is the big but. On the other hand, we are not going to realize these benefits from this natural gas unless 3 conditions are met. The first condition is that natural gas actually has to replace coal. If this simply becomes one more fossil fuel that we can burn, and until we burn them all up, it will actually end up with a net increase. So thinking about policies to actually replace coal are very important. The second thing is that methane is a very powerful greenhouse gas. It's about 34 times more potent when you look at a 100-year time frame. So unless methane leaks are very low, less than 3 to 6%, depending upon the calculations, there is no greenhouse gas benefit. So that's the second thing. We have to get rid of methane leaks. And finally, methane, or natural gas in the transportation sector, has very, very little climate change benefit. So if we think about what are we going to use this natural gas for, what we really like it to do is replace coal, not replace things like gasoline. And I'm going to stop right there.
Okay, Sally, thank you very much. Rob.
Well, hi, everyone. Good afternoon. So I'm the new kid on the block, not that I'm so new, but I'm brand new to Stanford and have been at Duke University for the last 15 years or so, and just arrived here. And over the last 5 years or so, have spent much more time than I expected really looking into natural gas and hydraulic fracturing in particular. So my group and colleagues at Duke published the first studies looking at drinking water quality and hydraulic fracturing. We've worked in the Marcellus, in the Barnett in Texas, the Fayetteville Shale in Arkansas. And one of the take-home messages that I'd like to leave you with today that we will probably talk about a little bit more is that with hydraulic fracturing, as an environmental scientist, I think what we should be worrying about most of all isn't what happens a mile or more underground, which is what gets most of the attention. It's everything else that happens near the surface. And that everything else includes workers on the well pads, people driving the trucks, water and air issues, drinking water that's a few 100 feet or 50 feet underground instead of water that's naturally pretty poor quality a mile or more underground. So let me give you some examples. From our water work, we found no evidence for some things people worry about, no evidence for an increase in radioactivity, people's drinking water from deep underground, no evidence of salts or higher concentrations of metals. What we have found pretty strong evidence for, in a subset, in a minority of cases, is increased stray gases in people's water, to the point where people's drinking water bubbles like champagne. So one of the issues that we spent a lot of time thinking about is why does that happen in the minority of cases and what can we do about it? And the first thing to worry about on the water side is the well integrity and what we do with the trillion gallons of wastewater we generate from oil and gas operations in the US every year. So then the other part of our research in this area is air issues. The people who are living near the pad, Sally's already talked about the very real benefits of substituting natural gas over coal for particulates, sulfur, and things. These are things that kill people in air quality. But for people living right next to the well pad, they're exposed to different things potentially, to organics like benzene that are carcinogens, hazardous air pollutants if you have leaks at those well pads. So another thing that we've done in my group is look at the distribution and extraction steps of natural gas to understand where the leaks are. So we, in the past year, have produced the first maps of natural gas distribution systems for cities. We drove every block of the cities of Boston and Washington, D.C., mapped 6,000 gas leaks in D.C. That's available on an app that you can download in your iPhone. So again, on the air quality, the water side, and long-term legacy issues I'd like us to talk about today. What are the long-term consequences of drilling millions of oil and gas wells over the next couple decades? And those consequences last for a long time. Thank you very much.
Okay, thank you. That was Rob Jackson, and now Marc Jacobson.
Hi, I'm a professor of civil and environmental engineering here at Stanford, and also director of the Atmosphere and Energy Program. And what I do is develop computer models to simulate air pollution, weather, and climate, and look at the impacts of different fuel sources and transportation types on pollution and climate, and also develop renewable energy plans for addressing pollution and climate problems. With regard to natural gas, the real question is, well, the two questions are, is it better than coal? And the other question is, well, even if it is better than coal, is it so good as wind or solar or some other alternative energy source? Because if the other alternative energy sources are better, then it's an opportunity cost to waste time spending money on something like natural gas. So if we just look at, like, for example, wind energy, it puts out like 1/50th to 1/60th the CO2 and air pollution emissions per kilowatt hour generated compared with natural gas. And while in the United States, the death rate due to air pollution from wind is virtually zero, whereas from natural gas systems, that's the production, mining, and use, it's about 5,000 premature deaths per year. And this is based on actual combining emission rates of all the chemicals associated with the mining, transport, and use of gas, then looking at the concentrations through numerical modeling of the United States at high resolution, and applying population and dose-response relationships for health impacts. So 5,000 people per year from the natural gas in the U.S., it's about 5 to 10% of the 50 to 100,000 people die prematurely in the U.S., and that translates into about $40 billion in health cost using statistical cost of life at about $8 million a person. So it's about 0.25% of the GDP of the U.S. So when we look at the comparison of wind or even solar or other renewable energy sources versus natural gas, I think it's pretty easy. But what about coal? So certainly coal puts out more carbon dioxide per unit energy than does natural gas. But natural gas actually puts out more carbon monoxide, more volatile organic carbon, more ammonia, more methane, and about the same amount of NOx, a little bit less NOx. Coal puts out more sulfur dioxide and more particulate matter. So coal actually has higher health impacts than natural gas. But it's ironic that the sulfur emissions from coal mask about half of its global warming. So although it kills more people per unit energy, when you combine CO2 and methane emissions from natural gas, especially on the 20-year time frame, which is relevant to the loss of the Arctic sea ice because it's disappearing so rapidly, maybe gone in 20 to 30 years at the most. When you look at that time frame, even methane plus CO2 emissions from gas are roughly equivalent in terms of their warming potential compared with coal. But when you add the sulfur emissions from coal, you offset about half the warming of coal. So there's anyway, I'll stop there and we'll talk about that later.
Okay, great. Thank you very much. And Michaelwara.
Hi, I'm Michaelwara. I'm an associate professor in the law school, and where my teaching and my research focuses on environmental law, energy law, and climate. And I'm just going to make a few brief points to hopefully seed your questions. I think it's unquestioned. It's without doubt the increase in drilling holes in the ground, and all the environmental consequences of that associated with the new innovations, right? Hydraulic fracturing and also horizontal drilling technologies has led to a whole series of really significant environmental impacts, both local in terms of the impacts on people that live there. Our environmental law clinic works with the tribes in North Dakota that are severely impacted by the boom in oil drilling, not natural gas, but oil associated that's happening there. I think it's important, though, to understand that the agencies charged with enforcing the law and with delivering to citizens some level of environmental quality are slow to respond. And they face enormous capacity constraints in terms of how quickly and the level of staff time that they can bring to bear on these questions. And so one thing as citizens engaging with questions about oil drilling, maybe in California, right? It's oil that we have in California, not so much natural gas, that will be accessed via the new drilling technologies. One thing to remember as we engage in this process is that the agencies we're dealing with are strapped for cash. They may have good intention, they may not, but it takes patience. The law moves slowly in this area, and environmental regulation in particular is complex and technical, and it takes time to get it right. And so that requires patience from everyone, especially the folks that want to protect the environment and do right by the people that live in a particular area. Another aspect of the California situation, I'm going to focus a little bit on California because I think that's important given where we are today, is who owns the resource, right? The other parts of the country where oil and gas drilling has exploded are typically places where the mineral right, the part of a property right that encompasses rocks and oil under the ground is in private hands. It may not be in the same hands as the surface occupant, and that can create lots of tensions, but it's in the hands of a private party. In California, mostly, although this is not completely true, but more or less, the mineral rights are in the hands of the federal government. Now, not in the hands, maybe California would like to have control its own destiny and own those mineral rights. We don't. The federal government does, but that's still a very different context, both in terms of how the rights might be accessed, how people who want to drill oil, Occidental Petroleum owns a lot of these rights at this point. They've leased them from the government. They don't own them, they lease them. But how those companies are going to be able to access rights, assemble large blocks of land from which they can drill if they get the technology right, and the incentives that people in the community may have. You can certainly read a very mixed story about particular parts of the country where some people who live in a community are getting rich from the gas boom, and some people are paying the costs and enjoying none of the benefits. In general, in California, the federal budget is going to enjoy the benefits, and California may pay some of the costs if we don't get the regulations just right. The last thing I would say is that if, I suspect, and I'm happy to, well, I suspect that many in the room are concerned about a big boom in oil production that's facilitated by these new technologies in California. They may be concerned for lots of different reasons. I would just say that you have to recognize that oil companies are patient. They are used to dealing with what they would characterize as regulatory risk all over the world and in much more extreme forms than is presented in California. And if you really want to change how those companies are going to behave, we need to think bigger than fighting fracking. We need to think about putting a price on carbon or a price on oil extracted from the ground, an excise tax. We've seen that on the ballot in the past in California, that changes the incentives of the firms to do or not do, to drill or not drill, based on the current global price of oil. And so thinking about these larger solutions is going to be a really important part of getting the incentives right, however you feel about accessing natural gas through new technology or oil through new technology in the United States. That's all I have to say for now.
Okay, great. Thank you. And Marc Zoback.
Yeah, I'm Marc Zoback, a professor of geophysics. About 7 years ago, my research group and I began to look at issues surrounding natural gas development, what the challenges were from sort of a geologic perspective to develop this resource. And at the same time, I got involved with a number of efforts, both at the national and international scene, on trying to assess the issues related to the environmental impacts and what those issues were and how we can control those impacts as best and reduce them to achieve the benefits as defined by my colleagues in their remarks. So I'll just kind of roll into this 5-minute overview I was asked to give, and a number of critical points have already been been made. I think the real question, and I'll restrict myself to natural gas because of this, this is a group interested in sustainability, and I think the key question is can shale gas and fracking, be a bridge to a green future? I think we all acknowledge the importance of decarbonizing the energy system, but it's a huge global system that we're talking about, and how do we get from here to there and over what time scale, and what's the role of natural gas? And it's my view, and it's the view of the president, the view of successive secretaries of energy, that natural gas is going to play a critical role in this transition. And we need good informed government policies so that it is in fact a transition, or if it's a bridge, so that there's something on the other side of the bridge when we get there. We all want to get to the same place. The real question is the role of natural gas sort of in that journey, because the scale of the problem is enormous. Between now and the middle of the century, when all of you are the age that we are now, we have to double the size of the energy system. We have to produce twice as much net energy while respecting economic growth, while respecting energy security, while reducing the impact of the energy system on the environment. And that's an enormous challenge. And it's that scale that really warrants this thorough discussion. Now, it is the immediacy of the ability of natural gas to replace coal for electrical power generation that makes it so attractive. The estimates that are in China are that 1 million people a year are dying from air pollution. So China has an energy security issue, it has a need for energy. It's importing coal right now. It's expanding its use of coal. India will soon be importing coal, that is if they're not importing gas. And the current situation in those countries will get worse before they get better because their highest priority is economic growth. Now, we need to recognize the priorities of these countries around the world and deal with perhaps an imperfect solution, but one that makes progress while more perfect solutions are evolving. As Pam introduced, hydraulic fracturing is just part of the process. It's an enabling technology. The reason all of this is happening, the reason it's been, this revolution has occurred in less than 10 years, is the recognition that the natural gas can be produced from organic-rich shales. These are rocks in which the organic material responsible for all hydrocarbons, these are the source rocks for all hydrocarbons, that the hydraulic fracturing enables the shales to produce enough gas to be an economically viable energy source. The reason for this is this organic material is trapped in clay, and this clay makes these shales 1 million times less permeable than a conventional reservoir, a factor of 10 to the 6th. Or if you have a granite countertop at home, or can imagine what one looks like, these shales are 100 times less permeable than the granite. So these are really impermeable systems, and that's why the hydraulic fracturing is used. Now, the unique aspect of this resource development isn't really the horizontal drilling and the hydraulic fracturing, it's the numbers of wells that need to be drilled. Hundreds and thousands of wells are drilled in areas which often have not had much drilling in the past. And there is simply no question that there are a number of environmental impacts, negative impacts, and these have been alluded to. And as I think Rob mentioned, it's become clear that the most important thing we can do is really pay a lot of attention to well construction. It's just a huge issue, and when wells are constructed properly, the problems, at least below the Earth's surface, largely go away. And the problems that have occurred in the past are really not related to hydraulic fracturing, they're related to poorly constructed wells. But there are many other problems, as mentioned. One of the problems, which hasn't been mentioned, is the occurrence of earthquakes. And what happens is after you hydraulically fracture a well, you flow back the water that was used to get it out of the way so the gas could flow. And when the water comes back, it picks up a lot of salt, minerals, contaminants like selenium, arsenic, iron, and it has to be disposed of properly. The most common way of disposing of the water is to inject it into wastewater injection wells. And in many parts of the country, these have recently seemed to be responsible for the occurrence of earthquakes, or at least earthquakes in much greater frequency than they've occurred in the past. We understand this process, how it occurs, and myself and 8 other professors have undertaken a series of studies to try to recommend proactive guidelines so that these problems can be avoided before they even occur. But it's a new environmental problem, it's a serious environmental problem, and it's one we have to get out in front of. But, you know, as is the case with all industrial processes, and this is what we're talking about, a new industrial process, you know, our job as scientists and engineers are to identify the problems and then identify appropriate, you know, solutions to those problems. And there's a lot of work underway, and a lot more work needs to be done to really reduce the environmental impact as low as possible.
Okay, great, thank you. I'm tempted to try to summarize everything they said, but that would take me the rest of the hour. So I think we should move right away to some questions and answers. I'm going to start with one, but I want you all to be thinking about what you'd like to ask, because we're going to turn to you next. So I want to tackle this issue of the bridge to a low carbon future. There are hundreds of years, I guess, worth of natural gas available in the ground, and we could use it in the near term with some, if we compare it to coal, some real benefits, at least in terms of greenhouse gases. We'd be meeting energy needs and doing that at the same time, so it sounds really good. But there is a challenge that has come up lots of times related to how fracking and the flood of natural gas will influence a transition to low carbon fuels, to the new energy future of renewables, and that remove the carbon and greenhouse gas problem for the long term. So there's technological issues related to that, and there are certainly policy issues related to that. And I want to start with Sally and Michael, and then anyone else who wants to join in can. But can you speak to what the options are for using natural gas either in the long term but without greenhouse gas emissions, or shifting?
Sure, yeah. So let's start with the short term. So, there's been tremendous progress in wind power, in solar power. It's absolutely phenomenal in terms of the performance of these, cost reduction, so it's really encouraging. And like Marc said, those are very, very low greenhouse gas emissions technologies. But the problem is that they operate when the sun shines and when the wind's blowing. And that leads to sort of an intermittency. And today's electricity system is basically designed to be on demand. We all go home, we flip on our lights, and we're just set up to do that. So we really need to find a way to balance the intermittency of renewable resources. And there are quite a few ways to do that. We can do storage. We can increase the transmission capacity, so there's power available from other places. Or we can use variable generation from facilities such as natural gas. So coal plants aren't particularly suited to ramping up and down. On the other hand, there are new gas turbines which can operate very efficiently in a very variable way and complement wind and solar. So I think in the short term, that's the big opportunity. In the longer run, we can employ carbon capture and storage technology for natural gas and basically reduce the emissions sort of yet another 50%, or not 50%, 80% over the emissions from natural gas. So I think those are the two opportunities.
Okay, great. And Michael, what would be required to make that happen?
Well, I think an issue right now is that we have a historically low natural gas price in this country because of the boom in drilling, because of the new resource we can access. And that's hurting coal. It's hurting coal in a big way in this country. I think about 40 gigawatts of coal has retired, and there's another 65 gigawatts or so of coal-fired capacity that may come offline in the near future. And in large part because of the economics of generating electric energy with coal versus gas. But at the same time, the low cost of gas has also hurt all of the renewable technologies that have to compete against it at the margin as well. And I think that just illustrates why the steps that the Obama administration are taking may be important. The steps to facilitate regulating greenhouse gas emissions from all electric power sources that produce them are important and significant, right? To start to create a bridge to somewhere rather than, as Pam, I believe, pointed out, a question about whether there is a bridge. Another big question about what the value of this resource is playing out really in Congress right now, which has to do with the question of exports. Right now, we have very limited capacity to export natural gas from this country. We kind of live in this isolated market where we don't have connections to other parts of the world that need the gas, that would like to buy the gas and are willing to pay much higher prices than in the United States. There are a number of facilities that are being built that would export the gas and start to make those connections between markets, and that has the potential to raise gas prices in this country, right? Which could be good in the sense that it's going to help the renewable technologies compete. Could be bad in the sense that it's going to help coal-fired electric power plants that make it to that end also compete. And so I think we have to think very carefully about how to balance all of these different policy imperatives, right? We'd love to reduce Europe's dependence on Russian gas right now. That'd be great if we could do that for a number of reasons that have nothing to do with environment or climate. But by doing that, by making that connection to the European gas market, we might introduce a lot of new factors into our own energy markets that might have intended or unintended consequences.
Okay, great, thank you. We could go on that one, but I do want to make sure that there's time for questions from the audience. Any questions right now? I'm dying to ask one about the hotspots and water and methane issues from the wells, but we can come back to that. Did I see it? Yes.
I have a question about the natural gas potential with India and China. You mentioned that that would be a better alternative to coal, or if they would have to depend on imported natural gas.
It's very mixed. Those are, two very rapidly growing economies, two very large emitters of CO2 and other pollutants from burning so much coal. China does have a yet unproven, but theoretically very large shale gas potential. So one would hope that while the Chinese will not likely be retiring coal burning plants, they'll be building gas burning plants instead of coal burning plants, and using natural gas instead of coal as heavily to fuel the growth of their economy. In India, they have a very large dirty coal domestic industry, and they're not going to be turning away from that. They also do not have very much potential, just for geologic reasons, to produce their own natural gas. But they are going to be importing energy in the near future, and right now the plan is to import coal to keep things going with a sort of a business as usual energy mix. The advantage India has, however, is that it's surrounded by large quantities of more or less conventional natural gas from the Middle East, from East Africa, from the Australian shelf, and so on. And so one would hope that the abundance of natural gas resources, if they can be provided at a competitive price, will allow India also to expand its economy and energy use using natural gas instead of coal. But they're very different situations in the two countries, except the fact that both are rapidly growing economies and they both have a rapidly increasing need for energy.
Great. Thank you. Yes, over here.
With the concerns over the leakage of methane from natural gas extraction, I was wondering if we have any good numbers on what that percent actually is, and is fracking natural gas extraction worse? Does it create more methane emissions?
Go ahead, Rob. Yeah.
So one of the things that there's a lot of work being done in this country in particular, but elsewhere too, looking at trying to estimate what the total methane leakage is from the extraction step all the way through to when the gas ends up in a power plant or in your stove, for instance. And some recent analysis have suggested that the break-even point for the comparison with coal is about 3%. And what that means is that if more than 3% of the natural gas that's produced leaks to the atmosphere, then the net greenhouse gas sum of that effort is a negative. So if it's more than 3% leakage, natural gas is worse than coal. It depends on the time frame that you use. The EPA suggests through their estimates that it's closer to about 1.5%. And I think it's fair to say right now, with a bunch of studies, primarily from aircraft, bottom-up studies from well pads, scrambling over well pads and literally looking at leaks from valves and hatches that are left open and things like that. Leaks from pipelines, as I discussed earlier. I think it's fair to say that recent studies have shown that the leak rates are higher than the EPA thinks, but probably not as high to cross that 3% bridge. And for me, the really important part of that discussion is that the leakage issues are easier to solve in this case than they are for coal, for instance. So if we can dial back or tune back those leaks, then we can make real progress. And I'll give you one specific example, and I'll be quiet. But we know that from the distribution step, which is the step that leaks the most methane, it's not drilling and extraction, it's downstream. And with the distribution step, the biggest predictor of leaks is old cast iron piping. You have the Harlem explosion, a 125-year-old pipeline out front of the building a couple of weeks ago. Right, now, states have done wildly different things. Ohio had a really aggressive pipeline replacement program. They started in 2001. They've gotten rid of almost all their cast iron piping across the state overall. I did an analysis recently to compare that to other cities across the country. Baltimore, Maryland is another example. They're on track to phase out their old cast iron piping in 2150, right? So 150 years from now. Now, that's not fast enough. So we know what we have to do. We just need better tools and technology for detecting the leaks and for fixing them.
I'll just add one more thing. There was recently a study that Adam Brandt, who's a professor in energy resources engineering, completed. And what they found was very interesting is that the vast majority of leakage is coming from a very small number of sources. So if you can detect those big leaks, you can then go remedy them. So.
Well, and that issue is that Rob brought that up with water, the water impacts as well. There's a small number of places where it's really bad news. And the question is, how do we find those small places and that small number of places, those hot spots, and deal with them? Anybody have an answer to that? Yeah. Yes.
Yeah. I just say one thing, I think the work coming out about where the leaks are coming from is fascinating, and it points to the need to create the right incentives for the firms that own the infrastructure. Right now, Rob's work has shown how leaky particular distribution systems can be. Part of the reason for that is that the firms that own those systems get paid no matter how much gas leaks, right? They basically measure how much gas they buy and they charge you for it, the end users for it, us, with our stoves. And we need to change those incentives and create incentives that make them want to go out and fix their systems. And the same thing goes for pipelines as well. All the pieces in the infrastructure where firms aren't essentially held financially accountable when they lose gas to the atmosphere and create the climate change harms that we're worried about.
Sure. Go ahead, Rob.
Just on the water, very briefly, I think the drinking water issue is this sort of hotspot perspective. But the wastewater issue is not a hotspot perspective. That's the trillion gallons I referred to that we have to do something with. And different states do really different things with that water. There are some states, 6, 7, 8 states in this country, where you can spray some of that water on land. There are states that use it for dust control on roads. There are bad things that we do, and there are smart things that we do with that water. One of the previously bad things was sending it to municipal water treatment facilities. They're not set up to handle the volumes or the chemicals involved. Some good news situation here. Industry has driven recycling of water increasingly in places like the Marcellus. That's a great thing. It cuts the amount of fresh water you need to frack the well. It reduces the amount of wastewater you need to get rid of on the backside. So if states are pathological about keeping track of this wastewater, making that information publicly available, and pushing those kinds of alternatives, we're better off.
Great, thank you. Marc Zoback, does that have a consequence for the seismic problems, earthquake risk, that recycling of water?
Yeah, very much so. It's the wastewater injection that's the principal problem, and if you were recycling water, that problem goes away. So it has multiple benefits. In fact, in the Marcellus in Pennsylvania, it's the lack of appropriate geologic formations to inject wastewater that led to the recycling, and that has the added benefit of not causing these other problems. So it's beneficial.
There's a question. Yes, please. And then over there.
My question is about water versus natural gas. The future of water related to fracking. And given that water is becoming increasingly scarce, is there a possibility that we might not be able to extract or exploit all our gas resources if water becomes very scarce? For example, specifically in China or Ireland, most of the shale gas resources are located where there's huge scarcity of water.
In some parts of the country, the use of fresh water is about 1% of the total fresh water used for all purposes. In other parts of the country, arid regions, the fresh water is extremely precious, and the hydraulic fracturing is competing with other more beneficial uses. The irony is you don't have to use fresh water. The operators simply prefer it. So we've all seen pictures of offshore drilling rigs. They're drilling wells with seawater. If they're fracking the wells, they're using seawater. And so there's a growing movement in arid regions to push the operators to use brackish water, saline water. In some areas like the Horn River area, which is very remote British Columbia, they actually drill new wells into saline aquifers. They do their drilling and operations with saline water, and then they return the wastewater to the saline aquifer and completely leave the freshwater system out of the loop. So it's like a lot of these other best practices. We kind of know what to do, but sometimes what industry is doing moves very slowly, and they need to be encouraged to move more quickly and lower their footprint before it becomes problematic. So there are options in many places.
Yes.
I was related also with water, the implications of fracking and water in places where we are having lack of offer of that, especially in Mexico, where the energy reform is opening. So I would like to know your thoughts about that.
Question of water availability, is that there?
Yeah.
In places where there's drought and really limited water, how are those decisions made? Who's negotiating that between, say, food production and fracking? Is it just the purchase price, or?
I spent a day in Mexico last week, so I guess that makes me an expert. The advantage Mexico has right now, if you're talking about northeastern Mexico, where the Eagle Ford Shale, which is being actively produced in Texas, is going to be produced under the new energy reform. And I sort of emphasized the fact that having not done anything yet, I think the Mexican government is in a very good position to plan for the cumulative impacts of that development far more intelligently than what we've done in the United States. And so that will include roads, pipelines, infrastructure of all types, as well as come up with a comprehensive regional water plan that makes sense. And it might make sense to prohibit fresh water and use saline water right from the outset, recycle the water or inject it back into saline aquifers. Anyway, there's a real opportunity in Mexico to do it right. And it comes back to this cumulative impact, because the one real difference in what's going on today with these shale gas wells is the sheer number of wells we're talking about, and how impactful the drilling, fracking, and everything else associated with that development is on communities and resources. And we haven't planned it very well in this country, and there's a real opportunity to do a better job in Mexico.
Marc Jacobson, did you want to comment on that?
Well, I guess I want to point to the bigger picture, that this again comes back to the question of well, if you're looking at any energy technology, you want to look at the impacts, all its impacts on the environment. So with natural gas, there's not only the water for the hydrofracking, but there's also the water for the thermal cooling, for cooling the gas plants, for example. There's the water vapor, the evaporative emissions, which water vapor is the most abundant natural greenhouse gas itself. So there's a water vapor from the combustion of methane. It's 2 moles of water vapor for every mole of carbon. But it's not only the water vapor, it's the land use degradation. It's there's the issue of the emissions, the pollution emissions. And so again, when we go back to this question of the bridge fuel, we haven't really answered that. Is this really necessary as a bridge fuel? Or can we go straight to renewable energy for all purposes? So Sally mentioned that, well, we need it for intermittency. Well, hydroelectric also serves this exact same purpose as natural gas in terms of balancing. In California and Oregon and Washington, all the northern states, they get Quebec Hydro, all the northeastern states. And in fact, so you don't actually need it. In fact, yesterday, Germany produced 60% of all its energy, electric power, from wind and solar. And in 2013, Iowa and South Dakota produced 28% averaged over the whole year of their electricity from wind. December 2013, Denmark produced 55% of all its electricity averaged over the month from wind. So as we go to higher penetrations of renewables, we see there is no intermittency problem. I'm not saying there won't be, but it's really more in the imagination of grid operators who are all worried about it. So we haven't answered the question, why do we need natural gas? It's a pollutant. It causes damage to the environment. There are other technologies that are better and cleaner. And so it just becomes an opportunity cost. Any natural gas plant that's built today is going to be there 40 years. So that's not really a bridge fuel, that's a permanent installation, or effectively.
Go ahead.
I'm just going to disagree a little bit with Mark here and maybe make things interesting. I think there are tremendous new technologies that may emerge and sort of scale over the next decade that are going to change the grid integration problem that we face now with renewables. But I would not characterize that problem as imaginary on the part of grid operators. In particular, the California Independent System Operator, which has maybe some of the most challenging grid integration problems in the country, because we have set, as our state has set, really ambitious targets that we are on target to meet in terms of the amount of our electricity that comes from wind and solar. But hydro is not always available. There are important environmental constraints on when you can and can't use hydro that have to do with the fish that live in the streams, the endangered fish that live in the streams, I would emphasize, as a way to integrate the renewable energy into the grid. And in practice, the grid operator is finding that they need to build new gas-fired power plants in order to manage the points in the day when the solar production tends to fall, when the sun is setting and when we're all getting home from work and turning on our houses, right? That's the challenging point in the day. And as far as we can tell, until we have good, available, cheap storage, the easiest way to deal with that at scale is gas. Now, that's not to say that that's going to always be true. But at least as far as the operators that are charged with keeping the lights on are concerned, and they have very strict reliability criteria that they have to meet, it's not okay for them to screw up once in a while and cause a blackout, right? If they do that, not only are they fired, and that's like the strong incentive for them, but the state, pays enormous economic costs from large-scale blackouts. As we know, we've lived through that, right? Or maybe some of us have. Probably not all of you were here. But I would just say that given the suite of technologies, given the need to scale, it's certainly possible that we could connect a whole bunch of much more renewable energy, but the choices that grid operators have to make are more limited than that. They don't have freedom to move along all dimensions in terms of costs, because we care about the energy costs in California, right? California has some of the highest electricity prices in the country. Other than Hawaii, we're number one, or we're number two. And we can't politically keep ramping that to do some of the things that one might do to avoid gas.
Can I respond? Well, first, California has...
Mark, really short, though.
Yeah, very short. So we actually have done a study on California's grid. I had a PhD student who did her dissertation on this exact thing, and she found that by combining wind and solar, increasing wind and solar using the exact same amount of hydro by month that we currently use for hydroelectric power and geothermal as base load, that we can match power demand with supply 99.8% of the hours over 2 years without an additional storage, just some concentrated solar with 3 hours of storage, in fact. So I disagree with that statement. And also, California actually is 13 cents a kilowatt hour. It's about the US average. New York's 18 and Hawaii is 33. And Hawaii is 33 because it's doubled in the last 10 years from 17 cents to 33 cents because of the cost of mining, transporting, and using fossil fuels. If you look at the 10 states in the US with the highest fraction of electricity from wind, the cost of electricity in those states were stable the last 5 years. All the other states went up 8%. Those are fossil fuel states.
Okay, thanks. Yes.
Sorry. Can we talk a little bit about the controversy surrounding the Monterey Shale here in California, and maybe your projections for the future in that and its relationship with the push for renewable energy in the state?
Anybody in Monterey Shale?
So the Monterey Shale is currently being, there are oil reservoirs throughout the state producing from parts of the Monterey Shale. The thought is that with horizontal drilling and multi-stage hydraulic fracturing, it can produce a lot more oil. About 2 years ago, there was tremendous enthusiasm about this, and then I think reality set in, and I think it was a regulatory reality. California is not an easy place for industry to operate in general. And the other is a geologic reality. When you're drilling a mile horizontally and you're trying to stay in the same geologic formation, that might be possible in the mid-continent where the geology is kind of layered and flat-lying, whereas in California it's highly deformed. So it's more challenging here, and it doesn't look like it's going to be a huge endeavor. We often get asked whether it's safe to do, and again, it has to do with the complexities of California geology. Areas of the Central Valley are about as stable and safe as any place you might imagine, but there's a lot of oil produced in the Los Angeles basin. A lot of people live there. There are a lot of active faults in the area, and so you really have to adapt how you characterize and assess what you're going to do in terms of the environment in which you're doing it, both the geologic environment and the population density, location of critical facilities, the possibility of intersecting active faults. So California is a difficult place to operate at many levels. Something may happen in the future, but it's not going to be the Bakken Shale and North Dakota all over again.
Thank you, Rob.
I guess I have a little different view. If oil prices go and maintain and stay over $100 a barrel, there's going to be tremendous pressure to extract oil from the Monterey Shale. It's a play that's probably at least twice as big as the Bakken Shale, and it won't be too long before the Bakken starts to slow down a lot. So, I guess I'm a little less optimistic about the regulatory framework slowing things down. It will be slower. It will almost certainly be more stringent here in California, but if the money's there, usually the oil and gas flows, and if oil stays high, the money will be there.
Yes, over there. We're almost at the end of our time, so we'll just take another question and try to wrap it up, please.
I'm taking Joel Swisher's class on greenhouse gas mitigation, and we're reading some of the increasingly strident kind of tone in the international reports about greenhouse gases. I have a question. Do you really think market mechanisms are going to work to limit climate change to whatever the global consensus in terms of what we need to do to prevent seeing unprecedented temperatures? I don't. I have very little faith that, if we have natural gas competing on the margin with 45-year-old coal plants, that this is any sort of a world that we're going to be able to leave to future generations. And so, I'm in the civil environmental engineering department. I'm interested in the technology, but I feel more and more like the technology's there. It's a question of advocacy. It's a question of aggressive policy. And it's a question of deciding what kind of a world we want. And so, I guess, especially given that the market contains giant powers that stand to gain a lot of money by continuing a reliance on fossil fuels. So that's kind of where I'm coming from. Do you think the market mechanisms and policy intensity the way it is right now are going to prevent catastrophic climate change?
Sally?
Maybe I'll take a crack at that. I mean, I think you're absolutely right. Market mechanisms aren't, we need to have a clear policy. You know, I think that a carbon tax makes a lot of sense, and it needs to be a carbon tax that everyone knows is going to progressively increase over time, so that people can make the long-term decisions to change the technology mix to achieve our goals. So I think that that's an absolutely critical step to sort of push us out of the sort of stasis that we've been in really since about 2008.
Michael, you want to add anything?
Sure. I mean, I think I agree very much with what Sally just said, and I would just add one thing. A carbon tax is a market mechanism. It's just a market mechanism where we don't have to create the market, the institution that has to support the policy from scratch. And I think that is a huge problem with the current market mechanisms that we have, where you've got an air regulator trying to make up a new market that's complicated, and where a lot of the players are going to be much more sophisticated than that air regulator. The other piece, which goes to what you said, you know, no regulation, whether it's a market regulation or a non-market, what you might call a command and control or prescriptive regulation source by source, is going to work if there's not political will to support it. Right? It doesn't matter, because the reality is that the command and control regulations, you take my environmental law class, I'll teach you all about it. Those are not enforced either if there's not political will to support the enforcement. Those just create a structure around which to bargain in the regulatory process. And so what's required is political will. And I hope that we generate it, you know, here and also internationally. But that's a complicated, different kind of problem than instrument choice.
Mark?
I haven't taken Michael's environmental law class, but I think I will. When you look at the role of government, I think it's come up in two different contexts. One is to establish long-term policies to get where we'd like to go, and that is a decarbonized energy future. You know, private industry is not going to do that, and the government has to create an environment through carbon taxes, other incentives, to get us where we need to go, and there's a very important role for government there. And the other is in the regulatory process. Shale gas development is a large-scale industrial process, and like other industrial processes, whether it's a refinery, a plastics factory, or flying in an airplane, we all feel better because of a functioning and effective regulatory system. And when you look around the country, Michael was being generous when he said regulatory systems are slow to respond. I sometimes say there are two kinds of regulatory systems out there, those with inadequate regulations and those with inadequate enforcement. There's probably places where both are true. So we really, if the benefits of this resource are going to be realized, we have to be serious about regulating the extraction process and doing the best we can to minimize the environmental impacts of that development.
All right, thank you.
Are we closing?
Rob? Yes, go ahead.
Yeah, if we're closing, I guess maybe the thought I'd like to leave you with is to, I think Mark is absolutely right that this quick transition to renewables, as quick as reasonably possible, is tremendously beneficial for water, for air pollution, for greenhouse gases. But it's not a simple thing, just let's go there in the next couple years. This will take decades to do. I think what I'd like to leave you with is the thought of this industrial activity in people's backyards, because that's where this happens now. Sometimes a couple hundred feet away from where people live, and they may or may not have an economic interest in that well that's right next to their house. So, when you land in a plane in DFW, where you drive from Denver to Fort Collins or Boulder, you see these wells springing up in areas where people are. And I walk down hundreds of driveways to sample people's water. And I've heard people who are really happy with the way they've been treated, with the money that they've gotten, and how things have gone. And I've heard people who are bitterly unhappy, in tears, and their life has effectively been ruined. And that's the bookend that you experience. And I think that the real question is how you shift that towards the people who are mostly happy. And I think that mix of the industrial activity right where people live is what we need to think about most.
All right, thank you. Now, it is already after 1, and I know there are probably a lot of other questions, but to respect all of your time, I think we should officially close this panel discussion, although those of you who want to stay might have a chance to talk with individuals of the panelists too, of the panel. But let me now thank them very much for sharing their knowledge with us, for sharing the discussion with us.